So I'm going to talk about three things basically. The various GemStone 64 releases, where we are with 2X, that's a real short piece. 3.0, reviewing what's new in there, and then what we're working on for 3.1. And that's basically it. Current release of 2.4. There's two different branches right now, 2.4.4.7 and 2.4.5. They basically are both bug fix releases with various difficulty of bugs in them. The next release we're planning, and hopefully the last release of 2.4, is 2.4.5.1, and that's got some minor fixes in it, as well as Power 7 certification on AIX, in which we had to redo some pretty low-level things to make things work correctly on Power 7 processor. And all the info you'd ever want and more is all out on the community site, where all our docs are, communitygemstone.com. So now on to 3.0. 3.0 shipped almost a year ago. Doesn't seem that long, but it is. June 15, 2010. And the major features are, we went back and re-implemented native code in 3.0, which is basically your just-in-time compilation of byte codes to native instructions on the processor. And with this, you get anywhere between 25 to 100% speed improvement, depending on what you're doing and how many message sends you have, and so on. But this has been a noticeably large improvement for a lot of our tests and applications. Something else we did is add an FFI foreign function interface where you can call out the third-party DLLs from Smalltalk without writing any C code. Okay. There's a detailed presentation out on the web somewhere on this. Martin did a presentation at ESUG 2010 on how to use the FFI, lots of examples. So if you're curious about that, I'm sure we can dig that up. We also added something called mid-level shared caches, which mainly benefit our really scalable customers that use a lot of gems, a lot of VMs, and a lot of caches. The issue here is bottlenecking on the database server, the Stone server, when you have many of the remote shared page caches, because everything ends up going through the same network interface. So you have classic, what we call star configuration like this. And we have one customer that's running over 500 of these. And when you do that and every session is busy, you can actually saturate a 10 gigabit Ethernet card, which they do routinely. And 100 gig is out there, but still really expensive. So to address this, we added something called mid-level caches, which is basically just another cache between the leaf caches now and the database server. So it basically gives you a number of additional places to look for pages before you have to go into the database machine. And this can provide significant relief for configurations that are highly distributed horizontally like this. Something else we added is external password validation, so you no longer need to have an encrypted password stored in GemStone to log in. You can use an external service to authenticate a password. There's two main options for this right now. One is LDAP, and the L in LDAP should not be lightweight, because it isn't. Having done the implementation. Anyway, and the other one is just a simple Unix password authentication where you call out to the traditional Unix API to authenticate, and that can be redirected to LDAP or PAM or a number of other places at the Unix admin level. So the way we do this with LDAP is you can have an alias for the GemStone user ID mapping to the LDAP user ID. They don't necessarily have to be the same. So it'll do a translation for you. With LDAP, we ship versions of the Open LDAP DLL and the Open SSL DLL with the product, so you don't have to worry about that. We ship those and load them because we want to know what version we're getting. If you've ever done anything with Linux, you know there's every version under the sun out there, depending on what distro you have. And the Unix password authentication just calls the old get PW name Unix calls to authenticate the password. And like I said, that can be abstracted and redirected to any number of authentication schemes depending on how your Unix environment is set up. Major step in 3.0 is multi-threading. Most of the database-wide repository operations, like garbage collection, integrity audits, listing instances, listing references, this is now multi-threaded. And you can specify how many threads or how aggressive you want to make it. Each thread is a unique GemStone session as far as the data stone and shared cache is concerned. It's really just an OS thread in the gem process, but each one takes a session slot. So everything on this list is now multi-threaded in 3.0, which makes things much quicker. The aggressiveness is controlled by two parameters, and these can be dialed up and down on the fly, which is basically how much of the CPU we saturate, total system CPU you want being used by these threads, right up to 100, and the number of threads you have going. And you can start and stop and dial up the threads on the fly. So, you know, if you're running overnight, you want to run really aggressive, you can, you know, just flatline the box, and then production comes in at 6 a.m., you want to turn it down to 1 or 2 threads, you can do that, all in small talk. One note about this is the default methods that are probably in your scripts for running all these different operations are not aggressive by default. And we did that just because we didn't want anybody to all of a sudden run 3.0 and not update their scripts and all of a sudden redline the box without knowing it. So there are versions of these methods that start with fast, which are the aggressive ones, and those just call other methods that, you know, take arguments that can be tuned. So you can roll your own on these as well. So there's examples of how to do it non-aggressively and aggressively. Another thing that we did is improving the cache warmers, and the cache warmers are something that optionally loads some or all of your database pages into shared memory before you bring production online to cut down the disk I/O required when an application or database starts up. This is now supported at the config file level, where the database will automatically start the warmers for you when the stone starts. Couple different modes: disabled by default is 0, run the warmers and load the object table and dependency map pages, which are the core metadata that GemStone needs to run, is a 1, and number 2 is try to load everything, and it'll automatically stop when the cache gets full, because a lot of times all the data will not fit in shared memory. And you specify the number of sessions or threads you want to run as well, from 0 to 256. The efficiency is much better in 3.0 for the warmers as well, because we traversing the object table in a much smarter fashion instead of a brute force fashion like we do with 2x. So it should run noticeably faster to complete the operation as well. Yeah?
So this is a theoretical question, but how do you know what to bring into the cache as you're working? Do you provide some code that gets run to indicate what object to get brought in?
No.
Remember what it was last time when the system closed and bring the same object?
No, it's not quite that smart. Basically, it starts bringing in every object in numerical order until it runs out of space. So it's not quite that smart, although you can write things that selectively bring in things you want, you know, in your own small talk code. But this code is not quite that smart. Proc monitor improvements: we improved the resolution down to a microsecond for sampling, because with the new faster VM, we were finding millisecond doesn't capture very much, which is a good thing if you're trying to run fast. It's a bad thing if you're trying to figure out where your code bottlenecks are. So this has been redesigned and improved, and I believe you can also get VisualWorks style reports out of Proc Monitor too, because a lot of people ask for that. Why can't you guys show a report like VisualWorks? And we took that to heart and did some work in that area. There's also built-in Monticello support in the extent when you bring up GemStone 3.0. In 2.x, sometimes the hardest part of getting some of the open source small talk stuff to load is getting Monticello to load in the first place. And once you get that in, you can load almost anything. So we've taken that task away and done it out of the box. I'm going to go through a few of the small talk changes in 3.0 compared to previous versions, kind of things you might need to know. The runtime array constructor has changed from square bracket to curly bracket, which I think is more in line with how other small talks do it. The compile time constructor, the round bracket, is not changed. So small talk code that has literal arrays in it may need to be modified. There's an option here in the second bullet where you can have 3.0 recognize and understand the old syntax while you're in the process of moving things around. So you can turn that on and off. So you can file in your code initially. And we've added a new byte array literal as well, which is a pound square bracket for specifying byte arrays and literals. That's brand new. Exception handling has been totally rewritten in 3.0 to use ANSI exceptions, which are class-based, instead of the old GemStone exceptions, which were error number, exception number based. If you know and like ANSI exceptions, this is a really good thing because it's totally compliant with that. So your exceptions are now all class-based for ANSI. So again, it gets more in line with other small talk flavors, which is something we've strived to do with 3.0. There's a list of new special selectors that get inlined by the compiler that are not really message sends, and the translation of that is these are really fast, so use them where you can. There was a shorter list of these around before, but this has been expanded to include all these new selectors as well. Probably the most misnamed class in GemStone forever has been Segment, which is our object security policy class, and that's been renamed to GS Object Security Policy in 3.0, which is much more descriptive of what it is and what it does. We have something called dynamic instance variables, which used to be something called tags, but it's been expanded and generalized a bit more. And this basically allows you to add instance variables to individual objects on the fly. Something that occasionally you want to do. Other languages like Ruby do this all the time. But if you need to stick something someplace real quick and don't have time to worry about instance migration, this gives you a way to do it.
Make it easy to then migrate it, or however you set up one of these dynamic instance variables, and then later you have the intention to move this normally. Would be that influence that migrate existing instances to the box.
Yeah, they'll come with it though. I mean, your dynamic ones, they're separate from the instance variable fields in the object, so it'll follow it. So if you want to, you want to add some objects temporarily to the dynamic ones, and then you want to move them later, you would just mill these and then put them over there. But I think the size of the object remains larger than it needs to be because it'll have these tags forever on those objects. I believe so. Because if you we physically have to grow a different part of the object in order to accommodate these.
So the remove dynamic instar wouldn't be.
That's a good question. I need to check that. It would be nice if it did, wouldn't it? Someone smarter than me may have already thought that. Large integer classes have changed in 3.0. Their large positive integer and large negative integer are gone. There's now just one class, large integer, and the bits for that are stored in native CPU order for better speed operating on those things. So if you're moving things around between different big Indian and little Indian hosts and you're actually looking at what the bits are, you'll care about that. But most times when you call it in the GCI or the API, it takes care of it for you. These are converted on the fly. There's no instant migration required. When the VM loads it, it'll switch it for you, and if you have one, you can send it the message convert, and it'll build a new one for you. Scaled decimal has been changed to a new format in 3.0. There's a new literal notation, the S notation, where you specify the mantis and the scale. This is ANSI compliant. And the old scale decimal in 2x has been renamed something called fixed point in 3.0. Because I know there was a lot of people, that's you, Bob, that didn't like the way we used to do it, so now you can kind of pick which way you want to do it. There's a new class hierarchy for meta class and class in 3.0. This ought to be transparent to most applications, but if you care about where meta class and class inherit from, this will affect you. This was done to accommodate some of the Ruby stuff we were doing in Maglev, where they've got something called modules stuck in the middle. After upgrade, existing meta classes become instances of obsolete meta classes, and newly created classes will have a class of meta class 3. Again, this all just works unless you care for some reason about this inheritance. Performance improvements, the round trips to the stone to abort a transaction has been reduced from 2 to 1 in most cases. That means aborts are quicker. Some fairly low level things here that I'll go through. The way gems talk to the stone is through something called the SMC queue, or shared memory queue. And 2x, that access was serialized by a spin lock written in assembler, but it was still serialized. So basically, one session would get the lock, put something in the queue, release the lock. The stone wanted to get the lock, it also had to wait for the lock to do it. So everything was serialized in order to add to this queue, which becomes a bottleneck when you've got 2,000 gems all trying to talk to stone at the same time. So in 3.0, we redesigned that to use atomic bit operations. So there's no serialization done at the programming level. There is some serialization done at the processor level, but that's extremely fast. So the way it works is every session has a unique bit and a bunch of shared words we have. And to get service in stone, you set your bit and wait. So there's no blocking. So multiple sessions from a programming API point of view can all request service simultaneously without getting a lock. And Stone, on the other hand, all they have to do is basically clear all the bits, find out who wants service to go and do it. So this gives quite a good speed up with throughput on getting messages in and out of Stone. What you lose with that design, though, is the queuing effect, where you know who got in the queue first and who got in the queue last, because you now don't have a queue, you just have a list of bits. So to deal with that, we implemented something called session priority, where for systems that are really sensitive to this, and there's probably not that many of these, you can basically tell the Stone, if I get all these sessions at the same time, here's the priority to service them in. By default, everybody gets medium priority to some of the background administrative gems, the reclaim and admin GC get the lowest priority. But it's important to remember that this really only comes up when the Stone has a choice to make about which one to service at the same time. The vast majority of cases, even in loaded systems, the Stone is only probably doing 1 or 2 sessions at a time when it pulls from the queue. And the session doing a commit or about to do a commit always has priority regardless of their priority. They always go to the front of the line to get the commits through. Another low-level change is how we do read operations in the shared cache when we want to look up a page. There's a hash table in the shared cache, which you could think of as essentially a dictionary that maps the page ID to the location or cache offset in the shared memory space. And as you can imagine, with a lot of sessions on the cache, that gets hammered pretty hard. And most accesses are reads. And again, in 2x, we had everything serialized by a spin lock by row. So you take the page ID, you hash that, you get to a row, now you have to get a lock for that row to do the search on it. And another guy wants to do that at the same time, he has to wait. So the lookup time is cumulative. For Gem 1 it's n, Gem 2 is 2n, and so on and so on. So it gets worse and worse as you go. And if you have deep collision chains, it gets worse again. So we realized that for read-only operations, this could be parallelized and possibly give a very nice performance improvement. And that's what we did in 3.0. Basically, we implemented another kind of lock, which is basically just a read lock. And any number of sessions can hold a read lock at the same time. in order to do the lookup. So assuming there's no writers on this row right now, which there isn't most of the time, all these sessions can do their lookup simultaneously. The read log basically says no one's allowed to change it, but any number of sessions can do the lookup. This gives a real nice performance improvement when you're hammering on the shared cache pretty hard looking up objects and pages. What else did we do? A new translog write system for writing transaction logs. Before, we used the OS AIO or synchronous IO write mechanisms, and there are various bugs in that on various OSs that give different performance curves and problems that we've hit over the years. So we decided to throw that out and basically just write our own, because generally what we're doing is a subset of what the vendor AIO system does anyway. So we basically have a configurable number of threads that we blocking writes to the translog, and a thread that manages them. And you can dial that up and down. And it's at least as fast, if not faster, than most of the AIO systems that come with the OS. A few notes on the upgrade from 2x. This is kind of a medium-sized upgrade. It's not as bad as upgrading from 32-bit or version 1 of 64-bit, in that there's no object migration required on instance migration. The object format is not changed. What has changed is the bytecode set, though. So that means that all Smalltalk code has to be filed in as part of the upgrade. The upgrade scripts that come with GemStone take care of all the kernel classes for you and get a basic running system, but then all the user and domain Smalltalk methods have to be filed in. You don't have to change your classes or migrate anything, but you have to file it in your code. There's other things I mentioned as well as that you need to be aware of. I talked about the literal syntax for arrays, for example, the scale decimal versus fixed point stuff. Do you want to use byte array literals anywhere? And the inheritance changes for class and metaclass if needed. Also, there's a new GBS version required as well. So you need to build a new image.
Question.
Yeah.
So if you were using the scale decimal and then you upgrade, does that migrate to the new class?
Those become fixed points. Yeah, just the existing ones.
Okay.
Yeah.
And then if you reference that scale decimal class in your code, then it says fixed decimal point right in there.
Yeah, you'll need to fix that if you want to keep getting fixed points from now on, if you like the way it is in 2x. So yeah, that's a good point. That needs to be addressed. There's various little things like that that have to be looked at when you migrate your code. We ran some tests about a year ago on comparing performance with the current version at the time, 2444 versus 3.0. This is commits per second throughput on Solaris 10, fairly modern machine with tranlogs on solid state disks and extents on MAR partitions with 16 gems. It's basically doing very small commits, hammering away as fast as they can. So you get a real nice gain here from about 1800 up to almost 8,000 maximum throughput. So we were real pleased to see that. On the VM performance, this kind of shows that it's kind of variable quite a bit. And this is building 5 quality indexes on a 2 million element collection. Pretty much everything in memory, again, tranlogs on solid state, extents on raw devices. The remove and build index code is probably spread equally between primitives and Smalltalk code. The audit index code, the middle graph, shows the greatest improvement is mostly Smalltalk code. Okay, so this kind of shows how your mileage varies here depending on what your code is doing. But in all cases, it's running faster. Just a matter of how much faster. Okay, that's it for reviewing 3.0. What we're working on now in 3.1, the first major feature we're doing is something called hot standby configuration. And this allows you to replay tranlogs live to one or more standby systems and keep them in sync. This goes across a LAN or a WAN to up to 5 standby databases. The translog replay is done in real time. There's the concept of a master database and one or more standby databases. There's new processes called a feeder on the master and receivers on the standbys, which are independent of the stone process, so these processes can be up when the stone is not running. They're designed to be fault tolerant, so if the connection drops, they'll just keep retrying to reconnect and send the translog records over until they catch up. So it's designed to be kind of run in a lights out, mostly environment. And the idea is here if you have to fail over, you know, you can bring this guy down, bring one of these up to take the place of production, restore the last translog and just go. These are multi-threaded processes. Basically, the feeder has a thread per standby database to send the data over. Right now, these are just socket connections, and we are doing some compression. In future, these may be SSL connections optionally as well. We don't have that yet, but that's the direction we're going. Some of the stone configuration options that kind of go with this, there's a new option called standby role, which basically says what role your database is in. Are you none, master, or slave? Default being none. There's a list of archived log directories to look in, which is your current directories for all your tran logs, plus any directories where you might be moving things off or archiving them as well. It's a complete list of places to look for tran logs to send over. And then there's, you can specify the net addresses and the net port to use, so you can get through firewalls for sending across the LAN. Something else we did is nested transactions. In 3.1, you can have up to 16 sub-transactions, which can be independently committed or aborted. Commit, though, really only commits out to the next higher transaction. It doesn't commit it to the database until you commit the outermost transaction. And consequently, concurrency conflicts with other commits are not detected until you get to the outer transaction. But you can commit to an outer transaction or roll back the changes you did in the sub-transaction to where you started without losing the entire set of changes you did in your transaction. So we think this might be handy in some applications. We've added IPv6 support as well. We're starting to get some requests for that, which if you ever want to do IPv6 on Windows XP, don't. It's kind of like half implemented. We managed to get it to work, but it was not fun. I'm not going to talk a lot about that. You can specify the listing addresses for Stone, and I believe those can be a mix of IPv4 and 6, depending on which interfaces you want to use. And IPv6 is explained in gory detail out in the RFCs. We're expanding our use of SSL in 101 as well. In 101, in 3.1, using SSL 101, RPC clients now always establish an SSL connection during login time. The connection may or may not be maintained after login is done. That's configurable, but we're improving the security in the way that we do passwords in normal logins and actually in all logins. So we're shipping the version of the SSL libraries now with 32-bit and 64-bit client libraries with GemStone, so you have them to log in. This should be transparent to most applications. It's all done in the login code. There is one extra round trip between Stone and Gem to do the SSL, which ought to be okay in most cases because it's fairly fast. We're adding Smalltalk support to SSL as well. There's a new class called GS Secure Socket, which is a subclass of GS Socket, and it supports certificates and client connections, server connections, basically a lot of stuff SSL supports. Procedure for setting this up is basically establish a normal connection first and then start SSL. So kind of similar to the way Unix does it. And it's a subclass of GS Socket, so most of your code to set up a normal connection ought to just work with GS Secure Socket, and then you have the option of switching over to SSL once you specify your certificate files and all that good stuff. There's examples in Smalltalk on the class side of how to set one of these up that work, so you can kind of step through it. And there's some readmes and examples on creating certificate files as well. Actually, there's a full example that starts creating right from a root certificate all the way down to a client certificate as you go. Configuration option on the gem side, to tell whether to use SSL or not is this. It's in the gem config file, it's off by default. What this means is after login, if it's turned off, the gem will revert to a normal socket connection by default. If you turn this on, it'll keep using the encryption for the life of the session. This only applies to clients that are remote from their gem. It doesn't make a lot of sense to have an encrypted connection on the same server. So if you're on a different server, you can do this. If it's the same server, it just silently turns it off after login is done. The way login is done, passwords are exchanged in 3.1 is something called SRP, Secure Remote Password Protocol. So there's a really neat set of key exchange things done by a guy at Stanford about 10 years ago named Thomas Wu. The paper's out there if you want to read it, and there's an RFC on it. But basically, you can do secure login without any certificates. There's no password exchanged at login time in any form, but the protocol allows you to prove beyond a doubt that both the server and the client know what the password is without sharing it. So this is what we're using in 101, in 3.1 rather, with OpenSSL 101 to do RPC logins. It's also used to store the passwords in GemStone in 3.1. So when a user profile changes, the password gets changed in 3.1, we actually store it as an SRP. You get salt and a verifier that are these really long numbers. Yeah?
Can you get that web address real quick again?
Sure.
Thanks.
Sure, and if you Google it, it'll come right up too.
Oh, okay.
But yeah, this is the original paper. There's a website out there on the Stanford page, kind of on different versions of SRP and what they've done, and there's at least one RFC on it as well.
Thanks.
Sure, and SSL 101 is the first version, including data support for SRP, so we're going to 101, which actually I think just released like about a week ago, so it's been in beta for a while. So the way this works is old passwords that you have migrated to 2x will continue to work until they're changed, but when they get changed, they get stored in the new format. If you want to be really secure as part of the migration or the upgrade, an administrator could go in and reset everybody's passwords, so they have to change when they log in, and then everything would be encrypted the new way. But we didn't want to force that on people. What else in 3.1? Automatic symbol garbage collection. Before 3.1, symbols live forever in all symbols, whether or not they were actually referenced by any domain class or anybody. We now treat all symbols as a weak collection, sort of. But it takes, we do this in the background, which is what it's designed to do, so it takes actually 2 garbage collection cycles to get rid of a dead symbol. But they are designed to go away in the background as part of normal GC. And actually, we had to turn this down because we found some of our own symbols were kind of not being used all the time and disappearing and then needed later. So we had to, a bunch of the symbols that come with the version GemStone extend have to be protected. It works almost too well. We've finished the multi-threading of the repository operations in 3.1, so full backup and restore from backup are now also multi-threaded. That completes the list of things that we wanted to do that was done mostly in 3.0. That makes these operations much faster. Miscellaneous changes. We had a request to allow non-system user logins to compile methods with primitives. So we added a privilege to let you do that if it wants to, if an administrator grants that. We also had a request to be able to configure the Unix permissions on the shared memory segment GemStone uses instead of the default of 660. So we now take that as an option. You can specify an optimal number in the config file, which tells which permissions you'd like the cache to be created in. There's also a new login hook, which is a piece of Smalltalk code that can get run every time a user logs in. In the past, there were ways to do that, but they were kind of black art voodoo a little bit. You had to plug it into internal methods that we use. This is a publicly supported way to do that. The method takes a block, a zero argument block or a symbol as an argument, and the symbol is a zero argument instance method selected for user profile, or it's a zero arg block, which can basically do anything. Obviously, this could be dangerous if all your sessions log into the same ID and you get a lock back in the middle of this, so. It's to be used with care, but definitely has some real benefits. There's a new public API for hidden sets, which are kind of internal collections that gems use that are memory-based. They're useful for looking at very large collections of objects and so on. We can use that. The API is previously marked private, although most customers were using it in some form, so we decided to go ahead and make that public formally. And we're working on some new UTF string classes that'll be in 3.1 as well. Don't have the exact details of that because the development is actually still going on there. There's a public source of libraries, I think called ICU, that you may be aware of that we're looking at porting in and shipping with GemStone to support some of this stuff. 3.1 schedule, we're on a yearly major release cycle schedule now, so we're looking at mid-June to ship this product and get 3.1 out the door. That's the current schedule. And that's the end. Is there any questions? Okay, thanks very much.